hardenability of, in this case, our 1045 steel. This is for in the future to learn and to know how to apply these measurements in an application that we want to achieve.
The Gemini test is a procedure to determine the templability. For this, you need a certain flux of water at a determined distance. This device what does is to cool down the bottom surface, and this allowed the piece to cool down gradually. For this procedure, first we need to prepare the oven at 900 degrees and also 400 milliliters of copper sulfate solution. The first step is to clean the Gemini specimen, and then we dip the piece into the copper sulfate solution for about 5 seconds. After this, we need to dry with hot air, and we put the piece to the oven for 30 minutes. And after that, we need it to be really quick because this step needs to be done in less than 5 seconds, and it's to take out the piece from the oven and put it into the hole of the Gemini device. The water will be flowing and the Gemini specimen will be cooled down gradually. This will leave different hardnesses on the piece. We'll leave the sample in the Gemini device during 10 minutes, and then we put it in a bowl of water in order to cool down completely.
After milling the test piece in the CIMA to remove the copper layer in one of each sections to be able to do the hardness test in the mechanic laboratory with the micrometric advanced device. We carry out the hardness test every 2 millimeters from the start of the test piece. All the obtained measurements were carried, and thus the experimental procedure was finished.
So this is our Gemini curve. The first two indentations are 1.5 millimeters apart, and then we did another 30 indentations, and they are 2 millimeters apart from each other. We can see that in the curve the hardness decreases while the distance is furthest from the bottom of the test tube type Gemini. This means that when we cool the test tube, the area that touched the water first faster, it cooled down and generated improvements in the mechanical properties. In this case, it improved the hardness. And the areas where the cooling took longer to reach, the hardness were less, and the properties were, in this case of hardness, were lower too.
The ASTM standard for this test is the A25510. Hardenability is a measure of the depth to which steel will harden when quenched from its austentite temperature. Severity of temper refers to the cooling medium, and it's designated with the letter H to the medium capacity for the cooling for absorption or for absorbing as much quantity of heat as possible in the less time possible. Critical diameter refers to the maximum diameter of the rod, which produces 50% martensite on quenching. The ideal critical diameter refers when the hardenability of a steel is the maximum diameter of the rod, which will have 50% martensite even if the core, when quenched, is an ideal quenchant. This diameter is known as the ideal diameter, or DI. Perfect temple refers to cooling the sample at certain temperature and circumstances that make the piece have the exact properties we are looking for. Correct temple refers to cooling down the sample in the shortest possible time, letting it have a good temple and avoid having any relation with the environment temperature. To determine the ideal diameter, first we need to know the austentite grain size, which in this case was number 7 because most of the steels are number 7. Then we have to determine the percentage of the carbon, which in this case was 0.45%, and relate both numbers on the table to get the first value, which is the DI Gemini. Then we multiply by each percentage of the other elements that we have according to the table, and we will have the diameter we are looking for. In this case was 0.2259 times 3, which was 0.67.
The cooling rate is the amount of degrees that increases or decreases in respect with time. In our Gemini test, it will be in respect of the distance. We know that our diameter is 0.6 inches. So using the table of cooling rate, we know that our cooling rate is at 10 Celsius over second.
The influence that the austenitic grain size has on hardenability is that if we increase one, the other one will also increase. And this happens because the grain boundary area is being reduced. So the sites for the nucleation of perlite and also for ferrite are being reduced in number, and since these transformations are being slowed down, then the hardenability will be increasing.
In this practice, I learned that it's very important to know the distances and diameters between one point to another in order to learn and analyze how that behaves and how the mechanical properties changes between one point to another one. Because if you want to put certain to a certain application, you cannot do that if you don't know how your steel in this case behaves.
I think that this practice was really interesting and also important because we could actually see how the temperature and the time during the quench actually affects our our material properties, because with this Gemini test we cool down the piece gradually, and this left different phases in the same piece and the different hardness, and it was really interesting to see the variation between the hardness in different points of the same piece.
In this practice, I was able to release how important it is to do the tempering process to be able to create the Martensita, since due to the rules of the Gemini test, what was done was to make the water jet under the sample, for which the tempering was not uniform throughout the length of the piece. In this part, it became harder, and little by little, its hardness decreased. In the result section, if the Gemini hardness curve of our test could be observed, even though there were values that went up and down.
My conclusion is that materials are very important in our everyday life, so making better materials will make our life simpler and more efficient. These procedures are very important because are the ones that improve the materials, which at simple sight we cannot know, but when introducing them into the industry, they make a huge difference, for example, in the machines they use. Our general conclusion is that the mechanical properties of materials can be modified to achieve better properties if the engineer knows how to perform certain procedures. This is very important in engineering because they are responsible of making better materials with better properties to achieve a better way of living.